I am Don Test, better known as the Donna Beer.
And I'm M. Sauter, better known as Pints and Panels.
Welcome to episode 93 of the All About Beer podcast. Every episode, we talk with leading experts and take a deep dive into one topic in beer. This week on the show, it's actually not a weekly show, but anyways, we are going to talk about the science of new yeast strains. This is going to be a nerdy one, and it makes me very happy. But before we get into it, please visit allaboutbeer.com. Follow us on social media at allaboutbeer. And please visit allaboutbeer.com/support to support this show and others. There's opportunities there for individuals and for businesses. So please visit that page. Em,
Yes.
this is going to be a nerdy episode, so I'm going to ask you a nerdy question.
Shocker.
What is your favorite yeast strain?
I like the Belgians because
Oh, you do?
I like the Belgians because the flavor of the beer is mostly dependent on the yeast strain. And I really like when the yeast gets to, be the star. A lot of the times you do not want the yeast to be the star.
Right. Are
And so
you
I really
pro or
enjoy.
con phenol producing?
I'm
Positive or POF
I'm
negative?
I'm I like it. I mean, if it's called for,
Okay.
then I'm all positive for it.
All
Especially,
right.
I
You
think
are
that
generally a positive person, I think.
sure. But I think that that's the yeast strains that I really gravitate to. Ones that they get to show off. What about you, Don?
Oh, I don't know if I have a favorite. I just
You
I love everybody. I love all the yeast.
you love all your yeast children equally.
I do. With the big lager trend, I do tend to like 3470. I mean, there's a reason it's so popular
Sure.
amongst the brewers, and it does a good job. So I'm gonna. That's a lame answer, but I'm a lame guy sometimes. Pardon
You
me.
said it, not me.
Okay, we will get into it. But first, if you would like to help support the All About Beer podcast, please reach out to podcast@allaboutbeer.com. Speaking of supporting this show, here is a word from our sponsors.
This episode is brought to you by Athletic Brewing Company. Athletic Brewing's non-alcoholic beer tastes so good, you won't believe it's non-alcoholic. Their brews are available at over 75,000 grocery stores, liquor stores, bars, and restaurants nationwide. Or you can grab some of their limited time offerings directly from their website. That's where you'll find exciting innovations like their first ever nitrogen-infused dark brew, Emerald Cliffs. And right now, you can save up to 25% and get a free glass and unlock access to exclusive brews when you sign up for the Athletic Club and purchase 4 or more six-packs. Go to athleticbrewing.com to get brews shipped directly to your door or find retailers near you. Near Beer. Terms and conditions. Certain limitations apply. Athletic Brewing Company. Fit for all times.
Escarpment Labs is the official yeast partner of Pink Boots Brews. Their Pink Boots yeast is a versatile German Kolsch strain that works across different beer styles. In light beers, it delivers bright, white wine-like aromatics. In hop-forward beers, it drives clean, citrus-forward biotransformation. Every purchase supports the Pink Boots Society, with 15% of proceeds funding scholarships and professional development for women and non-binary people in brewing. To place an order, email sales@escarpmentlabs.com.
Today's episode is brought to you by Salvo, a 100% hop-derived variety specific aroma extract from Hopsteiner. Get all the benefits of variety-specific concentrated hop flavor without the unnecessary bitterness or vegetal matter. Salvo provides clean, concentrated aroma, scalable dosing, and yield savings efficiency. If your kettle and centrifuge could talk, they'd ask for Salvo by name. Ready for a getaway that blends culture, flavor, and centuries of tradition? Head to Flanders, the birthplace of Belgian beer culture. This year marks a decade since UNESCO recognized Belgian beer culture as an intangible cultural heritage of humanity, and there's no better moment to experience it firsthand. Explore Trappist monasteries, cozy beer cafés, and innovative breweries that keep Belgium's brewing legacy alive. Raise a glass to history, hospitality, and the spirit of Flanders, where every pour tells a story. Start planning at visitflanders.com.
Richard Priest is co-founder and CEO of Escarpment Laboratories, a yeast producer and developer based in Guelph, Ontario, Canada. With a Master's of Science in Molecular Biology and Genetics from the University of Guelph, Richard leads Escarpment's R&D and product development. He specializes in yeast innovation for craft brewing and has published research on topics including Kveik yeast, hybridization, and Brettanomyces. His favorite beer styles are German Pilsner and Saison. Welcome to the show, Richard.
Hey Don, good to be here.
Yes, thank you. I love talking to you. Okay, so I'm a little bit familiar with Escarpment Labs. You have developed a reputation for developing interesting new yeast strains through bioprospecting, hybridization, and adaptive lab evolution, which are three different things. So, for the layman out there,
And
can
me,
you
don't forget about me.
and the layman out
The
there,
lamb. That's good.
um,
Yeah, I like when you make yourself laugh, Don. All right,
well, no,
continue.
yeah, I'm the only one I make laugh. Can you explain bioprospecting, hybridization, and adaptive evolution in lay M terms, please?
Okay, I'll try to keep it pretty brief. That I can go into detail on all of these. Hybridization is basically you take two different yeast strains and you cross them together. So, you make a new baby yeast, basically. Just like how different hop varieties come from breeding programs, different varieties of barley come from breeding programs. You're always trying to select for improved traits or combinations of traits, so that brewers have an easier time making beer or are able to get new flavors or new functionalities. So we do the same thing with yeast. We could take two different yeast strains and sometimes we're able to mate those together and make a brand new stable hybrid yeast strain that brewers can use. Um, Evolution. Oh, sorry, go
How
ahead.
does that happen? Like, how do you get two yeast to like smash together? I don't know. Like, I
A
to
bottle
make
of
something
wine
new.
and
I
some
don't. I
Barry
mean,
White.
so yeah. I mean, that does it for me. But
Yeah,
I'm
yeah.
not a single-celled organism.
You turn the lights down low and let the magic happen. No, it's a semi-scientific process. There's like two different ways to do it. One is called rare mating, and the reason it's called rare mating is that you're basically just relying on throwing a bunch of different yeast cells into a tube and hoping that they mate.
Oh,
So it's a great approach to use if the
that's like Tinder.
strains.
So it's
Yeah,
like
it's
pandas.
yeah, they're all just in the tube, just
Okay.
swiping left and
Okay.
right. Yeah.
Yeah.
Um, it, and you're relying on the rare chance that they actually are compatible. And you can get hybrids that way. That works great, especially for the beer yeasts, because they actually tend to be pretty not very fertile. Like they tend to have some inactivations in their ability to mate.
Hmm.
Um, and some of them are like totally sterile, almost
Why?
impossible to mate.
What?
Why is that? Are
A
they
lot of it
just
has to.
are they shy? Are they,
Yeah, yeah, they're just they're shy, they're
Too
nerdy,
many
they haven't
IBUs.
they're late bloomers.
Yeah.
No, it's because beer yeasts are so domesticated that some of them have just sort of lost that need. Like it's a super useful thing out in the
Oh,
wild for yeast to be able to like breed with other yeast and pick up create hybrids with new genetics and be successful out there in the wild. But our opinion is that beer yeast have gotten a little bit lazy and they just got rid of all the stuff they didn't need genetically, and part of that is in some cases in some strains or groups it's the ability to easily mate or sexually reproduce.
and sorry, we keep diverting you, but how do yeast sexually reproduce? Because they normally reproduce asexually, right? They just
Yeah,
bud.
yeah, the vast majority of time they just butt off. It's very simple. The sexual reproduction, you basically need two different cells. They also have something that's kind of like sex chromosomes. They have what's called mating types, but it's really just like one gene. So a yeast can be an A or an alpha. And if an A and an alpha get together, they can basically communicate through pheromones. It's super romantic, and
Hmm.
they basically can form what's called a shmoo, which is sort of like a little, like almost like a bud, but those two shmoos can fuse with each other and form a new yeast. I missed a step here where the cells have to sporulate first, but otherwise, yeah,
Those are some
they're
words.
yeast spores form schmooze, and those fuse, and then all of a sudden you have a brand new hybrid yeast.
Okay. 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 Now we diverted you away because there's two ways to hybridize. One is I already forget the term you used, the
Rare mating.
rare mating, and then dare I guess that the Other way is common mating?
That would be so simple. It's no, it's called
Okay.
spore to spore mating. It's more like test tube babies in this case.
Oh,
So what you're doing there is you're using a really fancy microscope that has a really, really delicate needle on it, and you take that yeast spore and you basically melt the outside of it with a special expensive enzyme, and then you can actually blast apart that spore. So the spore usually has four, or the spore zygote usually has four little yeast spores in it. You can break that apart, and with this fancy microscope, you can actually stick spores together on one location on a grid. So it's you're actually doing the work of sticking the yeast cells together. It's like yeast matchmaking in this case.
oh, okay. Cool. And I guess more precise then.
For sure, yeah. It also it can be a lot more efficient. Like you can make a ton of yeast crosses all at once
Oh, I
using
see.
that method.
And you know the crosses are all the same.
Exactly. Yeah,
Yeah,
it
I
just
figured.
requires like a really expensive, fancy microscope with
Okay.
fiddly parts.
And then let's go back to, but what is bioprospecting and what is adaptive lab evolution?
I mean, bioprospecting is just a fancy term for finding yeast in the wild, which I mean that's one of the things that I think is fascinating about yeast or fermentation in general is these things are everywhere. Like yeast is everywhere. Microbes are everywhere. The environment sort of selects for what you get. But if you go out into the wild, especially into places where there's sources of sugar, like trees and fruit, for example, you will find yeast. And some of those yeasts can be used to make beer. Sometimes you get yeasts that are not like the same species that we're used to. They're not Saccharomyces yeasts. They might be something else. But it doesn't mean they can't be used to make beer. And especially now as some of the applications or, beer styles or categories are evolving, some of that's becoming really useful, right? Like even, a lot of yeasts that are being used in non-alcoholic beers have come from bioprospecting.
Or Philly sour was
Yep,
bioprospected?
that's another one too. Yeah, I think that was found in a graveyard, or there's some
Oh,
story there. That's not
okay.
ours, but yeah, we Lalamond is a partner as well for us.
Why do you spend so much time in the graveyard? Oh, because I'm looking for
Looking for
yeast. That's
yeast.
honestly the answer. Lastly, adaptive lab evolution.
Yes. So, I mean, I've heard you, Don, describe it as strength training for yeast. So I'm gonna steal that term
Okay.
because that's exactly what it is. It's you're exposing a yeast strain to a certain stressful environment repetitively over and over through multiple generations of growth, fermentation, propagation, whatever you happen to be doing. And over time, what that does is it selects for random mutation in that population of yeast that gives that strain a competitive advantage. And so, if you get a random mutation that makes, say, you're selecting for high alcohol tolerance, you might get a random mutation in one of those cells that makes it grow a little bit faster than all of its neighbors. Well, eventually, that one strain, that one clone or mutant is going to take over the rest of the population, and you end up with something that's a little bit more robust or stress tolerant. And then those can stack on top of each other if you do it for 40, 50, 60 generations, and you can end up with evolved yeasts that are a lot better at a particular job. So, you can do that with alcohol tolerance or hop biotransformation, for example.
Ah, thiols.
Thiols, terpenes, we love terpenes over here too.
Yeah.
So when would you use each of these techniques for yeast? Is there specific strains that do better other ways, or is it just what you think will work best?
I mean, we're always trying to hit some kind of target. There's always some, objective. There's been a lot of focus on biotransformation and just flavor in general, but also a focus on efficiency and, just having really robust, stress tolerant yeasts as well. And, luckily it's possible to achieve both, a lot of the times with these techniques, where we would use the adaptive lab evolution is typically in a strain that we cannot breed. So, for example, we've had success using that technique in American ale strains where they tend to be quite sterile or really hard to breed. And then also we've had some success with that, even with some strains like the recently announced WLP Suava as well. So that's a strain that we collaborated on with White Labs. That was also lab evolved.
Hmm.
It's a farmhouse strain, but it also didn't breed very well. So we went that route to improve it. Whereas the
Yeah.
breeding is great, if it can form viable spores and breed, that's always a lot easier because the lab evolution takes a long time, right? You're like growing or fermenting the yeast for like 60 generations. Like it might take, 4 to 6 months to do that.
Oh, okay. That's nothing. Hops take like 10 years.
Yeah, we're lucky in yeast. It's a lot faster.
Um, so, you kind of talked about biotransformation, you talked about alcohol tolerance. Like, what are some other exciting things that you have done or are looking to do? I think that, a lot of people know about flavor-based things. You mentioned flavor, but sometimes it's also like, can you breed for temperature tolerance or speed or I don't know, working better in nutrient deficient environments, or I'm just making shit up now. But
All of the above. I mean, to be honest, temperature is really interesting. So, one area we are looking at is um, in particular, lagers. Um, if you could make a convincing lager that's fermented at 20 Celsius or 71 Fahrenheit, I think that would be really interesting to folks because it would just be so much more efficient. So that has been an area of interest. We have been doing some breeding of some new lager strains. We actually bioprospected a wild Saccharomyces eubayanus, so that's the lager parent.
mhm.
And then we've been crossing that with different Cerevisiae strains. So we've kind of been going back and rewriting history a few times and just seeing what comes out. And some of those strains are quite interesting, and they can make a pretty convincing lager at surprising temperatures or across a pretty surprising temperature range. So that's been really interesting. That's still very much an R&D. We have one of those strains that's available through our experimental program. We've been calling it True North Lager because it's kind of our first Canadian, truly Canadian lager strain. We didn't
Cool.
call it Canadian lager because I don't want to get a C&D from Molson.
Hmm.
Uh,
Fair enough. Um, I'm a science guy. I love science, but there's people who love tradition and everything. Like if you come up with a strain that can ferment a great lager at 27 degrees, how often do you get people go, that's awesome? And how often do you get people go away. I don't even want to try this. I don't want to taste it. You're full of shit. Get out of my face.
it's about 50-50, I would say. I mean, ultimately, I think as an industry, we do have to be open to new ideas or new resources or ingredients, so to speak. At the same time, it's important to also, have a platform for tradition as well. So, for those who want to make super traditional lagers, we have lots of options, right? There's lots of great yeasts available.
3470
However,
and 3470.
well,
I'm just kidding.
I mean, this is always my goal here is to try to make sure that we avoid, putting ourselves into the corner of monoculture,
Yes.
with our ingredients. I think that would be the worst outcome for craft beer.
Yeah. Okay.
What are the limits of like what you do and the techniques? What could you wish you could do but you can't?
Well, this was one of them, coming up with some new lager strains, and I'm happy that, at least on the R&D side, we've been successful there. So that's pretty cool. I will say one of the other big technical challenges is non-alcoholic. It's
Hmm.
really hard to find conventional Saccharomyces yeasts that don't ferment the malt sugars. Um,
Is
without
that
any
important?
kind of flavor compromise. Well, for non-alcoholic, it is because you don't want to make out any alcohol with those
Oh, but is it
fermentations, right?
important that it be a sack strain?
Well, that's a good question. The nice thing about Saccharomyces is we know it, we understand it. It's easy to work with.
I
It's
see.
easy to troubleshoot. Whereas when you get into the non-Saccharomyces yeasts, which there are some successful ones out there. We have a Hanseníaspora uverum. Say that 5 times fast. But it's great for NA beers. It actually produces less alcohol than a lot of the competing strains because it doesn't ferment fructose. So it's kind of a
Ah,
cool option there. However, the non-Saccharomyces yeasts are just, they might be harder to work with in certain ways. Like they might not flocculate the same, for example. They might have different temperature requirements, those kinds of things. So I would say that's one of the challenges is like finding a yeast that's works exactly like conventional yeast that's easy for the brewer to use but doesn't ferment those malt sugars. It certainly can be done through engineering as well, like you can just delete all the maltose fermentation genes, but that hasn't really been a focus of us.
Mhm. Um, you make it sound so easy. Can you give us a sense of how hard this is? Like when you're developing a new strain, how many hybrids do you do? Or you mentioned, it might be 4 to 6 months to do adaptive lab evolution. And then how often do you like put 3 years of research into something and then you finally have to throw up your hands and say, this, I just wasted 3 years of my life.
Well, I did grad school, so I mean, everyone has that feeling at some point. You're lucky if you have anything to show for it. But no, I mean, yeah, it does depend on the project. Some things can come together really quickly. Some things do take a lot of time. Sometimes we create something and then it's not actually, the use case isn't relevant until years later as well, like as the industry changes and things like that too. But in general, it does take some time. Like I always say, you can make a hybrid yeast in a weekend, but screening it and in testing it in breweries and verifying that this is something that has long-term value to the industry is going to take some time, right? Really that screening and scale-up process is where most of the cost and effort lies. So I could say, yeah, in any given project, we're going to make lots of hybrids. We'll make, dozens of hybrids. With the evolutions, we might make, 12, 16 different clones that we'll screen and compare to each other, or to the parental strain. And if we're lucky, one of those becomes a successful product, either as a liquid yeast or as a dry yeast.
Mhm. Cool.
So a lot of our conversation today has been quite nerdy, which is fun, and that's great. But is that what you do basically just like nerdy stuff for brewers, or do you think regular beer drinkers and customers should really care about yeast and how it's made and if
Like
so, why?
beer drinkers care about hop
Yeah.
varieties, yeah.
Hops. Yeah. I mean, they
So
care about some yeast stuff, but just like the like like I mean, there were some words in there that I'm just like, wait, what? I feel like I don't know if like customers like get into the weeds like that, and I think maybe they should, and like I wanted to know your opinion on that.
I think it's harder to communicate, the value or differentiation of yeast compared to something more tangible like a hop variety. And to their credit, the hop companies have done an extremely good job of branding their products and themselves, to the point where like every craft beer drinker knows what Citra is, right?
Mhm.
Um, I think we have some work to do on the yeast side, and in terms of achieving that level of sort of brand awareness. That being said, I think with the general consumer, the angle we have is flavor, and the
Yeah.
fact that you can develop yeasts with really unique and distinct flavor profiles through a wide range of techniques. Whether that's the evolution, bioprospecting, breeding, gene editing. You have a lot of different options that you can use to develop and tweak yeasts to have really distinct flavor profiles. I think that is something that is super relevant to the consumer. I think that's something that they're really looking for is, different flavors and as part of their overall experience.
yeah, I do think that the yeast companies such as yours are getting better now in terms of actually naming the yeast strains with names that are evocative rather than just a letter and a number, a serial number basically, right? So kudos to you for that.
It's all about marketing,
It's all about marketing.
always.
Well, Richard, I always love talking to you because you are very good at explaining things, scientific things in a way that I can understand. So I appreciate that. Thank you for your time, Richard.
Thank you guys. I'll come back
Cheers.
anytime.
Oh,
Wait,
you know
Richard,
what?
yeah, Richard,
Yeah, I forgot your social media
do you
handles.
have some social media handles you could share with us
Yeah,
before
you can
we sign
follow
off?
us. Absolutely. You can follow us at Escarpment Labs on pretty much every platform. And check out what we're up to. If you're in Canada, US, Europe, you can get our products, and we'd love to work with more breweries.
Awesome.
Awesome.
Thanks, Richard.
Thanks, Richard.
And we'll be right
Sure.
back with Nick Harris of Berkeley Yeast after a word from our sponsors.
If you're dreaming of a trip with character, charm, and world-class flavor, Flanders is calling. It's been 10 years since UNESCO honored Belgian beer culture, and Flanders invites you to celebrate this milestone where it all began. Walk through brewing traditions that span generations, meet passionate makers, and savor beers you won't find anywhere else. Come discover why Belgian beer culture is more than heritage. It's a way of life. Plan your journey at visitflanders.com. Let's talk about brewhouse efficiency. Replacing pellet loads with salvo can not only boost aroma density, but reduce true load and increase beer wort. Seems like simple math, but if it's still not obvious, replacing pellets with salvo can give you more beer per batch with better brewhouse efficiency. Salvo, designed for brewers who are tired of sacrificing yield for aroma.
Escarpment Labs is the official yeast partner of Pink Boots Brews. Their Pink Boots yeast is a versatile German Kolsch strain that works across different beer styles. In light beers, it delivers bright, white wine-like aromatics. In hop-forward beers, it drives clean, citrus-forward biotransformation. Every purchase supports the Pink Boots Society, with 15% of proceeds funding scholarships and professional development for women and non-binary people in brewing. To place an order, email sales@escarpmentlabs.com.
This episode is brought to you by Athletic Brewing Company. Athletic Brewing's non-alcoholic beer tastes so good, you won't believe it's non-alcoholic. Their brews are available at over 75,000 grocery stores, liquor stores, bars, and restaurants nationwide. Or you can grab some of their limited time offerings directly from their website. That's where you'll find exciting innovations like their first ever nitrogen-infused dark brew, Emerald Cliffs. And right now, you can save up to 25% and get a free glass and unlock access to exclusive brews when you sign up for the Athletic Club and purchase 4 or more six-packs. Go to athleticbrewing.com to get brews shipped directly to your door or find retailers near you. Near Beer. Terms and conditions. Certain limitations apply. Athletic Brewing Company. Fit for all times.
Nick Harris holds a PhD in microbiology from University of California, Berkeley, where his research focused on discovering new molecules and characterizing novel enzyme functions using advanced analytical and biochemical techniques. Driven by a passion for both science and brewing, he co-founded Berkeley Yeast, which continues to push the boundaries of yeast bioengineering for the brewing industry. Welcome to the show, Nick.
Thanks for having me.
I am looking forward to this because you are going to explain to me how you edit genes in yeast, which is something that I, as a former lawyer, have no understanding of.
Sounds fun.
I mean, I think people don't have some vague understanding of what genes are. So maybe start there. How do you look at what genes are there and then decide this needs to go or this needs to stay? And then how do you do that? And I'm ignorant enough that I don't even know if that question made sense.
No, that's a great question. Let's start, maybe we'll start small and then go big. How's that?
Okay.
So what is a gene? A gene is a sequence of nucleotides. If you've seen Jurassic Park, you've seen on their computer screen all the A's, T's, G's, and C's. Basically, when those are strung together in a long genetic sequence, what they provide is the code for life. So all organisms read DNA in groups of threes. So they take 3 of those nucleotides and read them at 3 at a time. That's called a codon. And that codon encodes an amino acid. And so a gene sequence would be a sequence of these codons, each being the code for different amino acids, which will piece together an entire protein or enzyme. So an enzyme or protein is just a string of amino acids that twists up together, and when it's all coiled up, it can become active. And that protein or enzyme, those two words are kind of used interchangeably, can do biochemical work. So for instance, a terpene synthase is a type of enzyme that is encoded by a terpene synthase gene, and that terpene synthase will make terpenes. And terpenes, just so that everybody's on the same page, are a highly abundant class of compound or chemical or molecule, however you like to say it, found all throughout nature. Pinene is the smell of pine trees. That's a terpene. There are a lot of different terpenes out there, but so basically, let's just get back to it again, is that a gene is just a code for producing different proteins or enzymes, which then do biochemical work. And when we're thinking about beer yeast, for instance, yeast has a lot of different genes, and many of these genes encode for enzymes that produce different esters, aldehydes, alcohol. They encode the yeast's ability to consume sugar, the yeast's ability to flocculate. All of the different traits that yeast have, those are all encoded by different genes. So when you change the genetics of an organism, you thereby change its phenotype or the traits that that organism has. So with genetic engineering, and I don't think we've gotten that far into this conversation yet, but with genetic engineering, you can very precisely change one nucleotide at a time
Oh,
or multiple nucleotides at a time to either change one enzyme, one protein. You could change the shape of that protein and change its activity. You could remove a protein altogether so that the yeast, in this case, no longer has the ability to do something. So, for instance, if you were to delete a gene that encodes some sort of ester biosynthesis pathway, the yeast would no longer be able to produce that ester anymore. You can add in other genes from elsewhere in nature and then give the yeast new abilities. So, one thing that's pretty cool is that all of life has genes, and all of life can, for the most part, can read genes from other organisms. Life is pretty fluid. We all speak the same genetic language. And so yeast can read the DNA from a tree or from a tomato plant, and produce the same proteins that those organisms would produce out in nature. And that will give the yeast the ability to produce the same compounds as those plants.
okay. There's a lot there. Holy cow. So whether it's a pine tree, a human, a yeast, we're all ATGCs. Like it's all the same language.
That's right. And there are, I mean, of course, it's more complex than that.
Yeah.
And I mean, I did get pretty deep there right off the bat. So, but yeah, of course, there are exceptions. There can be other little pieces of DNA that are stuck in the middle of genes. And not all organisms read these genes exactly the same way. But yeah, for the most part, all of life uses the same genetic code to produce different biochemical outcomes. And whether it's a tree or a yeast strain, the genetic code itself can produce the same biochemical constituents.
Okay. Fascinating.
So, what can you do with gene editing that you can't do through hybridizing? Is it just more exact?
There are multiple things, but for hybridizing, you can't introduce anything new that those two. So for hybridizing, you're taking two different yeast strains and you're crossbreeding them. So there's a transfer of genes, and it's like you just said, it's not very precise. So when you're trying to transfer one gene, you end up transferring a lot of genes altogether. It's kind of like shaking an apple tree to try to get one apple to fall. You're going to get a lot of apples falling. With genetic engineering, you can be very precise and intentional to make that one apple drop. So it's like going up to the apple tree and just pulling that one apple off because you can transfer genes literally at the single nucleotide level of precision. But you can also introduce genes that yeasts don't have. So when you're doing hybridization, you can only use what the yeast already has, basically. So if you wanted to get a yeast strain to produce more thiols, you can't get there with hybridization. Hybridization, you would be transferring one enzyme. Well, the goal would be to transfer an enzyme that encodes a highly active thiol producing enzyme, but that doesn't exist in the yeast world. So it's not possible with hybridization. Now, with genetic engineering, you can go out into nature and find the most active enzyme for doing any specific thing. So in this case, you could take a highly active thiol producing enzyme from somewhere else in nature, whether that's from plants or other microbes, and put that into yeast. And then you would confer the yeast the ability to produce thiols at levels that you would never be able to achieve with hybridization.
Okay. And I think what you're doing now is what's called non-cis gene editing, because you're taking genetic information from a non-same species. Species isn't probably the right word, but organism,
Yes, so
and
you
putting it
can
in
you
a
can do either. Yeah, you can do either. Cis means the same. Trans means from something else. And so if you're using cis genes, that would be from the same organism. And
yeast to yeast.
yeast to yeast, that's the same thing as self-cloning. And you can use genetic engineering to either just remove a yeast gene that maybe you don't want there, or you could put in another yeast gene. And there are lots of genes. There are lots of reasons to do that, by the way.
Mm.
For instance, you can tweak, you could remove the yeast's ability to consume maltose and maltotriose to make a non-alcoholic yeast strain. You can do that all without introducing any foreign DNA. So that
Right.
would be technically a self-cloned strain, and many countries in the world wouldn't even consider that to be a GMO.
Okay.
You can turn up ester biosynthesis using just yeast genes. The extent to which a gene is turned on is controlled by a small regulatory sequence in front of that gene called a promoter. It's like a dimmer switch for genes. You can insert higher strength promoters using just yeast genetic material and modulate gene expression. So you can use a higher strength promoter from yeast, put that in front of a yeast ester biosynthetic enzyme gene, and you could turn up ester biosynthesis. So there are plenty of edits that you can make using genetic engineering and using just the cis approach or self-cloned approach.
Uh-huh.
But if you get into using transgenes or foreign DNA from elsewhere in the natural world, that just increases the possibilities of what is possible. But even with the cisgene approach, there are still a lot of advantages of using that over hybridization. So, for instance, if you were trying to make a maltose and maltotriose negative yeast strain, a non-alcoholic yeast strain using hybridization, pretty much the only way to get there using hybridization is to crossbreed with a wild yeast strain. And the problem with that is that wild yeast have not been domesticated over centuries throughout the process of selection by brewers. And so they produce off flavors. They lack process efficiency traits. They don't ferment quickly. They don't flocculate. They don't produce a lot of beer flavors, so they don't overproduce esters. All these traits that brewers love, you would be transferring those into the recipient yeast during the process of making it maltose and maltotriose negative. So when you're doing hybridization with a wild yeast strain, you can end up with all sorts of baggage that you don't want.
Right.
But using genetic engineering, even the cis approach, so just self-cloned approach, you can create a wonderful strain by making it precisely maltose maltotriose negative. You can turn up esters so it tastes more like beer. And because you're starting with a domesticated brewer's yeast, you're already starting with something that flocculates, that ferments quickly, that reduces aldehydes, etc. So it's just a much more precise way of generating the traits that you actually want in the right host organism.
Right. Got it.
What do you say to people who think GMO necessarily means bad?
I don't think that there are that many people that think that anymore.
Oh,
I
okay.
think I think that is something that we used to hear quite a bit about when we first started. I think it was more of a fear that people would talk about. It was not
Sure.
something that they weren't the ones that were scared themselves. They were always talking about this perceived fear of the public. I think that most people these days understand science quite a bit and can understand that if you take genes from an edible plant and put it into a yeast strain, and the yeast strain is now producing different edible compounds, I don't think most people have a problem with that. Or in the case of the
Hmm.
maltose negative yeast strain, if you're making a self-cloned yeast using genetic engineering, you're just tweaking yeast genes. So you're not creating anything new. And I think that most people understand that there's just nothing unsafe about that process. There's not really anything unnatural. And in fact, it's more natural than the alternative. So there are a lot of non-alc beers out there right now that aren't using self-clone GE strains. And because they're not starting with the right starting organism, they then have to spike in natural flavors and they have to add in all of this other stuff, or they have to use these really complex dealc processes that use a lot of energy.
Mm.
So I think when you're weighing risk to the environment or to human health, actually using GE techniques can yield a more natural result than using something that's just found off. It's kind of interesting that using science can actually get you to a more natural place than not use, than using a wild yeast, for instance, and then having to doctor it up with flavorings. So I haven't seen too many people who are actually still afraid of GE. I think, of course, like any technology, there are potentially bad use cases of GE. And I think that what we saw is way long time ago, decades ago, is that Monsanto came on pretty strong with using genetic engineering techniques that weren't benefiting consumers. For instance, they never released this, but they talked about it, launching Terminator seeds that would kill themselves at the end of a growing season so that you'd have to keep on buying seeds from them. People, of course, are not going to be behind that. Roundup ready crops that are herbicide resistant so that you are encouraged to spray more glyphosate on your crops, and the plant is resistant to that so that they can sell more of that chemical. So, I think that that's where a lot of the fears for GE started. But I think since then, especially in the beer realm, where there are companies who are making different yeast strains, for instance, that are benefiting the consumer. They're making more flavorful beer. They're letting you make non-alc beer with less chemical inputs. I really think that people can get behind that, and that's really what we've seen from consumers and the brewers as well. But we've seen a lot of people just get behind the technology because it's being used in a caring way that supports the consumer.
Hmm. So, if I can be devil's advocate, then is there anything bad about these types of yeast strains? Like, do they you can't repitch them as often, or is it more expensive, or any of those kind of brewer concerns?
Nope. You can repitch these strains just like you repitch any strain. Of course, you have to be smart about the genetic engineering. So try not to be salesy here, but we have a line of yeast that reduces diacetyl, and we are now on our fourth set of those diacetyl reducing strains. The first one, first couple that we came out with, we were producing way too much of the enzyme ALDC. Now, ALDC is what turns the precursor from diacetyl into the end compound acetone. So it bypasses diacetyl formation. ALDC is pulling from the branched chain amino acid pathway. So when you're overproducing ALDC, you end up with less amino acids for the yeast. And we saw early on that yeast health could suffer if you were overproducing ALDC. So in that case, you wouldn't be able to repitch it too much. But now we're on, our fourth iteration of it. We've dialed in gene expression. So that strain is really good right now. But So as long as you're smart about the genetic engineering and dialing in gene expression or trying out different gene variants, et cetera, you can get it to a place where it's just as robust as normal yeast. So yeah, you can repitch them. And no, our yeast it's priced on par with other yeast strains. So um, I think a lot of people expect it to be more expensive because there's so much R&D work that goes into creating these strains, but the reality is that it's just about as costs just about the same for the brewer, and they end up with a bunch of extra benefits, though.
Cool.
What is a frontier you're working on that you're really excited about? So like in 2 years from now, there may be a yeast that can do something. I don't know. What's on the table for you guys that you can talk about?
Yeah, I think glitter production. Um,
What I mean,
Wow.
no, I'm just joking. I'm just joking.
I think that would be cool, but it's also me. So, but anyway,
Yeah,
continue.
yeah.
Glow in
Fluorescent
the dark
glitter.
yeast?
Yeah.
Yeah.
No, I'm really excited about the non-alc space. You know, that's just it's booming right now. I know for myself in the type of lifestyle that I have two kids. I try to get after it in the backcountry with mountain biking, skiing, etc. So, just being able to do all the things that I love, I just find myself drinking a little bit less, but I love beer as well. So, I'm really excited to continue to develop better non-alc yeast strains to make beer that tastes more like actual beer, just so that I can balance my love for beer with my active lifestyle and family lifestyle. Um, and I think we already have some pretty good non-alc strains, but I'm excited to keep on improving them. And yeah, I'm also just excited about yeast strains that can get out of the way for brewers. So we used to focus a lot on flavor production, and these days we're focused more on reducing off flavors. So I'm just really excited to produce the cleanest possible yeast strains so that brewers can chef it up. They can be the magicians. They can layer all the flavors that they want into their beer, and the yeast just plays a background role and just gets out of the way. Because there are a lot of, different yeast derived flavors that aren't great or can detract from a beer. And, our goal is just better beer everywhere. And I think we all just want more drinkable beer. And so I'm just excited to be a part of that.
That's
Amen.
awesome. Yeah. Thanks, Nick.
Yeah.
Before we let you go, can you share your social media handles so people can follow every cool thing that you're doing?
Yeah, so our social media, Instagram is where we're most prolific. It's Berkeley underscore yeast. Berkeley is spelled with as many E's as you can possibly fit into it. It's Berkeley and then underscore yeast. Um, you can follow us on Facebook as well. It's most of the same post as Instagram. And yeah, but feel free to reach out to us. We have a ton of good resources on our website for we have different recipes. We have collab brewer stories. We have a whole section on non-alc beer, recipe tips, etc. Don't hesitate to reach out. We love to be a part of it. So
Let's talk yeast.
yeah, we love to talk yeast. We love to talk beer. We've got a lot of really talented brewers on our staff right now, and if we just want to be along for the journey, and yeah, please reach out and take us for the ride.
Cool. Thanks, Nick. This is great.
Awesome. Thanks for
Yeah.
having me. Appreciate it.
Cheers.
Cheers.
So, Em,
Mm-hmm.
you have a new favorite yeast now, or
Nope, still.
no? Still.
So that saison, like a saison yeast is like
Yeah,
really where it's at.
they could
I really,
hybridize it and make it more
mm.
saison-y.
No, it doesn't need to be. You can't fix perfection.
Okay.
There were a lot of words in there that
Did you like that though, or
no, I liked that. It definitely I learned a lot
yeah,
in this episode, and it's something that a lot of people don't think about yeast in these kind of like how do you bump esters up? How do you
yeah,
create NA beer using just yeast? There's so much possibility and stuff that like you can like it's just really cool. It's fun to see the potential and the technology and science behind it.
yeah. I do think that. I mean, I think that yeast is fundamental to beer more so than barley or hops because you can theoretically make beer from any grain or and hops was actually a relatively new ingredient in beer. But yeast is what makes beer beer in terms of
Mm-hmm.
fermenting it into alcohol. So this is the foundation from which we should be thinking about flavor or the alcohol production or, production in terms of time and temperature and all that. So I think that's really cool. I like this episode.
Yeah, very cool.
Before we let you go, everybody, please visit allaboutbeer.com and follow us on social media at allaboutbeer. And as always, we'd like to ask you to please visit allaboutbeer.com/support to support this show and others. And if you have questions for the experts, please email podcast@allaboutbeer.com. That's also the email for feedback, suggestions, or to inquire about supporting this show through advertising. Em, how do
Yes.
people reach out to you?
I am at Pints and Panels on Instagram, Facebook, and sometimes, rarely, but sometimes I'm on Blue Sky. And my
Okay.
website is www.pintsandpanels.com. How about you, Don?
I am at the Dawn of Beer on X, Threads, Blue Sky, and Instagram. On Facebook, I'm at the Beer Dawn. And my email, dawn@thedawnofbeer.com. That's where I love to receive questions and comments because I like to nerd out on beer. And here's a friendly reminder. Please help us grow this show by giving us a 5-star review. Whatever podcasting app you're using, just drop us a 5-star review. We would really, really love that. And here is a final word from our sponsors.
Searching for a destination with deep roots and unforgettable tastes? Discover Flanders, home to one of the world's richest beer cultures. This year marks the 10th anniversary of UNESCO's recognition of Belgian beer culture, a perfect reason to explore the breweries, cafés, and traditions that shaped it. From monastic brewing to modern craft, every sip connects you to centuries of expertise. Experience the warmth, the stories, and the spirit of Flanders. Begin your adventure at visitflanders.com. What can I say? Once you go salvo, you don't go back. Better yields, repeatable performance, and fewer hop solids to drag you down. No more heavy hop loads, no bitterness spikes, just variety-specific hop flavor. It's the easiest way to sharpen your aroma profile while improving your yields batch after batch. Find out more at shop.hotsteiner.com or ask a sales rep how Salvo can help you.
Escarpment Labs is the official yeast partner of Pink Boots Brews. Their Pink Boots yeast is a versatile German Kolsch strain that works across different beer styles. In light beers, it delivers bright, white wine-like aromatics. In hop-forward beers, it drives clean, citrus-forward biotransformation. Every purchase supports the Pink Boots Society, with 15% of proceeds funding scholarships and professional development for women and non-binary people in brewing. To place an order, email sales@escarpmentlabs.com.
This episode is brought to you by Athletic Brewing Company. Athletic Brewing's non-alcoholic beer tastes so good, you won't believe it's non-alcoholic. Their brews are available at over 75,000 grocery stores, liquor stores, bars, and restaurants nationwide. Or you can grab some of their limited time offerings directly from their website. That's where you'll find exciting innovations like their first ever nitrogen-infused dark brew, Emerald Cliffs. And right now, you can save up to 25% and get a free glass and unlock access to exclusive brews when you sign up for the Athletic Club and purchase 4 or more 6-packs. Go to athleticbrewing.com to get brews shipped directly to your door or find retailers near you. Near Beer. Terms and conditions. Certain limitations apply. Athletic Brewing Company. Fit for all times.
This show is produced by All About Beer. Please visit allaboutbeer.com for articles, notes on this show and others, and to connect via the newsletter and social media. Cheers!
Cheers, everyone.